In this video, we are going to talk about how to combine like terms. Let's start simple. Like terms are terms that have the same variable and the same exponent. For example, 3x and 2x here are like terms. Remember, there is an implied exponent of 1 here because they're only being multiplied by their coefficient one time. On the other hand, 3x and 4x squared are not like terms because the exponent is different. And constants like 5 and -7 are also like terms with each other. They are just numbers that you have always been adding and subtracting, which is really all combining like terms is. And to help you feel a little bit better about this, we could just write an assumed x to the 0th power beside every constant. Because remember, any number raised to the 0th power is just going to be 1. It's just going to be 1. So no matter what value this variable takes on, it is still just going to be 1. And any number multiplied by 1 is just itself. Now let's actually have a go at combining like terms. So here we have 4x and 7x. We could confirm that these are like terms by noticing that both numbers are being multiplied by x to the first power. And first, I want you to intuitively understand what we are doing here. So what we're actually going to do is kind of reverse distributive property and factor out an x because it is a common factor of both of these terms. So we could take this x and bring it out front, which is exactly what we are going to do. So we could rewrite this expression here as x times 4, and I'll write this in blue, sorry, as 4 plus 7. It's 4 plus 7. So now we have x being multiplied to 4 plus 7, and you could check if this expression is equivalent, and you could use the distributive property, and it would equal this. So now what we're actually going to do is just add 4 and 7. So I'll rewrite this, x times, well, what is 4 plus 7? That is just going to give us 11, and we could just rewrite this as 11x. And hey, we have turned these two terms into one. And you don't have to do all of this every time you combine like terms. The key realization is all you have to do when combining like terms is just add the coefficients and stick on the variable to the end. So in this case, we could just add 4 and 7, which would give us 11, and then stick on the variable, which was x. So now let's practice simplifying this pretty messy expression by combining like terms. And I'm going to color code, so let's first identify all of the like terms. So let's identify all of the x squared terms with red. So here we have 9x squared, that's a y squared x, 2x squared, and 4x squared. And then for the y squared, we could do that in blue, which it appears we just have one of these. And then there are two x expressions, or terms, sorry. All right, well, let's combine these. So we know how to combine like terms. Let's see, and I'll write these in red. Let's see, 9 plus 2 is going to give us 11, and then plus 4 will be 15. So here we have 15x squared. And the process is the same if you have a very, very large amount of like terms, as it is with 2. All you have to do is add up the coefficients and then stick on the variable to the end. And then let's do the x term. So we have x minus 3x. Well, there's an implied 1 here, and we're subtracting 3, so that will be -2. So this will be minus, and I'll write these in white, minus 2x. And then let's see, we only have one y squared term. And we did it. We turned this expression with 6 different terms into a more simple, easy to look at expression. And that's really the point of combining like terms. They just help you simplify expressions so you get a better idea at what you're looking at. And when you move on later into your mathematical life, you'll notice that combining like terms is actually necessary to solve problems. All right, let's look at one more problem here. And you'll notice there are some terms with multiple variables, but the process is really the same. A term is a like term when it shares all of the same variables, all raised to the same exponent. And if it were the case that this had an x squared term, well, these would not be like terms because this variable has a different exponent. But for this example, all of the variables are raised to the power of 1. So let's go ahead and identify all of our like terms. And as I mentioned, 3xy is a like term to negative 5xy because both of these have x to the first power and y to the first power. And then there are two x variables, or sorry, two x terms, 2x, and then negative x or negative 1x. And then there is one y term, and I'll do this in green. And then we can just leave our constant 7 here in white. All right, so if we were to combine the xy terms, well, this is 3 minus 5, which gives us negative 2xy. And then for our x terms, well, this is going to be 2 and then negative 1, which will be just 1. So this would be plus x. And then for our y term, this is going to be just 4y by itself, which will remain the same. And the same thing is true for our constant here. The same thing is true for our constant 7. So we'll just add on 7. So now let's kind of finish up by doing one more problem. And this one is a little bit more challenging. So we can see here that we actually have parentheses and a constant multiplying multiple variables. So let's kind of simplify the parentheses first. And you'll notice here we can't really do anything with 9x to the third plus 3x. So let's just rewrite it down here. 9x to the third plus 3x. And what we're actually going to do is use the distributive property to distribute this 3 here to this expression here, which is 4x to the third plus x. So this will give us minus the quantity 12x to the third plus 3x. And you'll notice here there is a negative sign, so we're actually taking away this entire expression here. So when we simplify this, this will be 9x to the third plus 3x minus, because we're taking away 12x to the third, and then minus 3x. So let's just do what we have been doing and identify the like terms here. So our like terms are going to be x to the third, which is 9x to the third, and then negative 12x to the third, and then 3x and negative 3x. So let's just combine like terms here. So 9x to the third minus 12x to the third, well, that is going to be negative 3x to the third. And I'll write that 3 a little bit smaller, negative 3x to the third. And then 3x minus 3x, well, that's just going to be 0x. And whether this x ends up being 0.1 or 10 million, this is just going to simplify to 0. So when we add 0, that does nothing. So our simplified expression here is negative 3x to the third, which is a whole lot simpler than this messy expression up here. So hopefully you can see some value in simplifying expressions by combining like terms. And we are done.